Hi, hello dear students, welcome to Karnataka Sslc classes. Okay, in the last class we have seen what is called a BPT, okay? The statement of BPT, proof of BPT. So we can use BPT when a line is drawn parallel to any one of the side. Okay, then the other two intersecting lines are divided in the same ratio. Okay, that is called to be BPT, or it is also called to be Thales theorem. Okay, in today's class we will discuss about what is called a converse of BPT. Okay, converse of BPT means in the BPT statement, okay, there are two things. One is given and what we need to find. Okay, so the given statement in BPT becomes here we need to prove. Okay, and in the BPT what we proved, that is going to be here as a given statement. Okay, that's what we call it as a converse. Okay, now see the statement. If a line divides any two sides of a triangle, okay, in the same ratio, then the line is parallel to the third side. Okay, so you can see if I break this complete statement into two parts, okay, into two parts, into two parts, okay, into two parts. So the first part, if a line divides any two sides of a triangle in the same ratio, means it is given. It is given. So this given was proof in the BPT, isn't it? So here it is given statement. What we need to prove? The line is parallel to the third side. Okay. So we will consider a triangle. Okay. And also we will write the given thing. I mean ratios are equal. Okay. Then we try to find the line is parallel to the third side by indirect method. Okay. Okay. So first we'll consider a triangle. Okay. So consider. So it is under proof. Okay. Okay. Proof. Okay. Consider a triangle ABC. Okay. Consider triangle ABC. Okay. Such that. Okay. Such that. Okay. So AD by DB equal to, okay, AE by EC, okay, as shown in figure, as shown in figure. Okay, so here we draw figure. So let me take a triangle. Okay, we take a triangle. This is a triangle. Okay, name of this triangle A B C. Okay, and what we need to prove? Okay, so we need to prove that AD by DB equal to, okay, this is given, AD by DB equal to DAE, okay, AE by EC. Okay, it is given. What we need to prove? That DE is parallel to BC. That we need to prove. Okay, so what we'll do? So here we need to do some assumption. Okay, so assume, okay, assume DE is not parallel, is not parallel to BC. So naveen assume madam, DE BC ಗೆ parallel ಇಲ್ಲ ಅಂತ first assume ಮಾಡೋಣ. Okay, so if D is not parallel to DC, some line should be parallel. So say DE dash, okay, is parallel to BC. Okay, so what we consider, DE dash is going to be parallel. Okay, so we'll draw. Okay, so DE dash is parallel to BC. Okay, now once I assume DE dash parallel to BC, okay, shall I use BPT? Okay, so I'll use BPT here. Now according to BPT, according to BPT. So I can write, if DE dash is parallel to BC, I can write the two sides are divided in the same ratio. It means AD by DB is equal to AE dash by E dash C. Correct? AD by DB equal to AE dash by E dash C as per the BPT, because already I said DE dash is parallel to BC. Okay. Now we'll compare. See, this is a given thing. Okay. So this is given. So I'll call it as equation 1. This is given. And this is as per our assumption. As per our assumption, DE dash parallel to BC means this is the result we got. This is the result. Now you compare equation 1 and 2. Equation 1 is straightforwardly the given statement, the given condition. The second one is what we are assuming. Okay. So if you compare both equation 1 and 2, left hand side is same. Okay. AD by DB, AD by DB, AD by DB. So if LHS part are same, you can equate RHS part. Okay. So that you can write as from 1 and 2. What I can conclude, that RHS parts are equal. AE by EC equal to, here RHS part is AE dash by E dash C. Okay. This is an important result. Now, after this we need to prove that the AC of both the equations, we should get AC for both the numerators. Now you just think, how can I get AC from AE and EC? If I add AE plus EC, I'll get AC. Similarly to this side, if I add AE dash plus E dash C, I will again get AC. So that AC can be said equal, or AC you can cancel them, isn't it? So in order to add a numerator and denominator terms, you always have to add plus 1. Okay. So when you add plus 1, the numerator is added to the, the denominator term is added to the numerator. Okay. So adding both the side 1, so I can write AE by EC plus 1 is equal to, this side also I want to add denominator to the numerator. So again I'll add plus 1. Yes. So it is going to be 1 into EC. So it is going to be AE plus EC by EC, and this side AE dash plus E dash C by E dash C. Correct? Okay. So I'll continue here. What about AE plus EC? Okay, AE plus EC is same as AC divided by EC. Now again, what about AE dash plus E dash C is same as again AC by E dash C. Okay, so you can cancel them, sides are equal. Okay, so you can cancel, it means here you'll get 1, okay, and here also you'll get 1, so cross multiply. So this indicates EC equal to E dash C, E dash C. So you can think, when EC equal to E dash C, okay, EC equal to E dash C, it means what we assumed E dash, okay, should coincide with E. Okay, the E dash should coincide with E. Okay, so that I can write, I can write that E dash coincides with E. Okay, when E dash coincides with E, the line segment DE dash is also coincide with the DE. Okay, and we assumed already DE dash is parallel. It means when DE dash is parallel, even DE is also going to be parallel. Okay, so I can write DE, therefore I can DE is parallel to BC. Okay, it is parallel to the third side. Okay, So what we did, we first used the given statement. According to the statement, we wrote, okay. So for the statement such that a line divides, the line is DE, okay. This line DE divides this triangle as AD by DB equal to AE by EC, okay. Till that time he has not given anything about BPT, okay. Just he said the line divides the two sides in this ratio, okay. I wrote that one. In the second case, we need to prove this line as to be parallel. For that, what we have done, we have assumed one more line which is parallel to the BC. When we have assumed that to be parallel, we have applied a BPT. So as per BPT, I wrote the statement. From the statement I wrote the equation. Now you can compare equation 1 and 2. So after comparing, you will get RHS parts are equal, okay. And we can get AE plus EC to be AC complete side, okay. Either AE plus EC or AE dash plus E dash C will give you AC. For that, I am adding +1 to both left hand side and right hand side. So I am getting this result. So after adding, you will get AC and AC. So after cancellation, you will get EC equal to E dash C. What this implies, okay, these two line segments are equal, okay. EC and E dash C are same. It means I can say E dash, which we assumed, okay, E dash coincides with the E. E dash coincides with the E, okay. So E dash coincides with E means E dash we assumed to be parallel. It means that assumed parallel line coincides with the DE means even DE is also going to be parallel to BC. So this is the converse of the BPT, okay. So whenever you see converse of some theorem, okay, so in that theorem what is given, okay, that needs to be proved, and what you proved that is given as a statement, okay, that we call it as a converse of a given theorem, okay. So this is very important, because in the next exercise and in the subsequent exercise also we are going to use both BPT and the converse of BPT, okay. So have a practice, okay, and try to understand both BPT and converse of BPT, okay. So okay. So in this video this much. So in the next video we'll start with the first exercise, very important, okay, and from the exercise you will come to know how to apply BPT, okay, and how to understand BPT by applying to particular triangles, okay, and also you can understand the converse of BPT, okay. So we'll continue in the next class. Thank you.